In this video, we will see how we can calculate the value of RAB, that is the resistance of the circuit across the terminals A and B. To calculate the value of RAB, we will start with this and we can see that this 1 ohm and 5 ohm resistances are connected in series. So we can replace these two resistances by a single resistance of 6 ohms. So if we replace these two resistances by a 6 ohm resistance and redraw the circuit, we get a circuit like this. Now we can again see that this 4 ohm and 6 ohm resistances are connected in parallel. So these two resistances can also be replaced by a single resistance, and the value of that resistance is equal to 6 into 4 divided by 6 plus 4, that is 24 divided by 10 ohms. So if we replace this 4 ohm and 6 ohm resistance by this resistance and redraw the circuit, we get a circuit like this. Now if we carefully saw this circuit again, we can see that this 3 ohm and this 6 ohm resistance is connected between point C and point B. So we can say that these two resistances are connected in parallel between these 2 points. Similarly, this 12 ohm and 24 by 10 ohm resistances are connected in parallel between points D and point B. So these two resistances can also be replaced by a single resistance connected between these 2 points D and B. So what we will do in the next step, we will find out the equivalent resistance of parallel combination of 3 ohm and 6 ohm and connect that resistance between point C and B, and then we will find equivalent resistance of 12 ohm and 24 by 10 ohm connected in parallel and connect that resistance between point D and point B. Parallel combination of 3 ohm and 6 ohm will give us a resistance of 3 into 6 divided by parallel combination of 3 ohm and 6 ohm will give us a resistance of 3 into 6 divided by 3 plus 6, that is 2 ohm resistance. So we will connect a 2 ohm resistance between point C and B. Similarly, parallel combination of 12 ohm and 24 by 10 ohm resistance will give us an equivalent resistance of 12 into 24 by 10 divided by 12 plus 24 by 10. And if we solve this, we will get again a 2 ohm resistance. So let us redraw the circuit. We have a 10 ohm resistance and a 1 ohm resistance. This is point C, this is point D, this is point A, this is point B, again this is point B, and this is point B. Between C and B, we will connect the equivalent resistance of 3 ohm and 6 ohm, which is equal to 2 ohms, like this. This is 2 ohms. Between point D and B, we will connect the equivalent resistance of 12 ohm and 24 by 10 ohm, which is again equal to 2 ohms. This resistance is 1 ohm and this resistance is 10 ohms. We can see again that this 1 ohm and 2 ohm resistances are connected in series, and equivalent of these two resistances is equal to 3 ohms. So if we replace these two resistances by their equivalent resistance, that is a 3 ohm resistance, we will get a circuit like this. Now we can see that these two resistances are connected in parallel, and the equivalent resistance of these two resistances is equal to 2 into 3 divided by 2 plus 3, that is 6 by 5 ohms. So if we replace these two resistances by a single resistance of 6 by 5 ohms, we will get a circuit like this. And now we can say that RAB is equal to the series combination of 10 ohm and 6 by 5 ohm resistances, which is equal to 56 divided by 5 ohms. This will be the answer.